Here we go for this lesson 2, proving identities practice. So we're just practicing using those identities, and what identities we're talking about are these ones. Okay, and we added one in here, right? The a squared plus b squared with the a plus bi, the imaginary numbers, and a minus bi. Okay, so these are the ones we're using. So let's get started. So it says factor. So we've got x to the fourth minus 81. So factoring means we need to take it bigger. So what situation do we have? Well, we have this one, a squared minus b squared. So a squared minus b squared, you're going to get a plus b times a minus b. So what would that be squared? Well, we'd have to go backwards, so it would be x squared squared minus 9 would, or 81 would be 9 squared. So a is x squared, b is 9. So I'd go x squared plus 9 times x squared minus 9. Okay, now if we look at 3, okay, that's kind of the same idea, except it's plus, not minus. So it's the a squared plus b squared one, which is a plus bi times a minus bi. So what would this be squared? Well, 4 is 2 squared, x squared is x, so 2x plus 100 would be 10 squared. So we'd have 2x for a and 10 for b. So 2x plus 10i, because now we add in the I, times 2x minus 10i. Okay. Now if we're doing it with the cubes, okay, remember the cubes was different, right? It was these guys, a plus, then a minus, then that a squared guy, and it was the opposite. So it would be a plus b times a squared minus ab plus b squared. Okay, so what cubes are we dealing with here now? So this would be x cubed plus 64 would be 4 cubed. So we'd have a and b, so we'd go x plus 4 times, well, a squared, a is x, so x squared, minus a times b, x times 4, so 4x, plus b squared, so 4 squared, 16, and that's what our answer is right there. Okay, so now 4 and 5, we're going to be using Pascal's triangle, okay, and that binomial theorem. So what is term 4 in row 12? So let's bust out a triangle. So remember, we start with row 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then term 4. Remember, we start with 0, so 0, 1, 2, 3, 4. So the fourth term would be 495. Okay, now when we're expanding, we use that exponent, tells us what row, right? And it tells us what to start our coefficients with. Okay, so or our coefficients and our powers. So I know it's going to be something a to the 5th, b to the 0, plus something a to the 4th, b to the 1st, plus something a to the 3rd, b to the 2nd, plus something a squared, b to the 1st, plus something a to the 1st, not b to the 1st, b to the 3rd, b to the 4th, plus something a to the 0, b to the 5th. Right? Because that's the pattern. We start with the highest for a, it goes down by 1 until we get a to 0. For the b's, we start with 0, then it goes up 1 until we get to the maximum power. So let's see what those coefficients are. So 5th row, so we have 1, 5, 10, 10, 5, 1. Okay? So 1, 5, 10, 10, 5, 1. Okay? Now we know that a is negative, 2x is a, and b is y. So So I start plugging them in. So 1 times negative 2x to the 5th times y to the 0 plus 5 times negative 2x to the 4th times y to the 1st plus 10 times negative 2x cubed y squared plus 10 times negative 2x squared times y to the 3rd plus 5 times, and I may have to scoot this out of the way, 5 times negative 2x to the 1st, y to the 4th, plus 1 times negative 2x to the 0, y to the 5th. Now, we know anything to the 0 is 1. We know timesing by 1 is pretty worthless. So, we start out with negative 2 to the 5th, which I believe that would be a negative 32, x to the 5th, right? 2 times 2 times 2 times 2 times 2. If they're negatives, there's 5 of them, so it stays negative. 4, 8, 16, 32, yeah. Plus, now negative 2 to the 4th would be 16, right? Positive, because they're negative. So we've got 5 times 16 x to the 4th, y to the 1st, plus 10 times negative 2 to the 3rd would be negative 8 x cubed y squared, plus 10 times negative 2 squared is 4 x squared times y cubed, plus 5 times negative 2x y to the 4th plus y to the 5th, because the other ones eliminate. And then we finalize, so negative 32x to the 5th plus 5 times 16 would be 80x to the 4th y. Now I could go plus a negative, or I could realize it's negative and go minus 80x cubed y squared plus 40x squared y cubed minus again 5 times negative 2, negative 10 x y to the 4th plus y to the 5th. And there is my expanded polynomial. Woo! Pretty crazy, right? Alright. Now, let's kind of go and keep doing this. So 6, it just wants the second term of this expanded form. So we've got the power of 11, so we're going to the 11th row, and it wants the second term. So I go 0, 1, 2, so 55 is my coefficient. Okay, then A and B. So A at 0 term would be A to the 11th, B to the 0, because that's how we start. So this would be A to the 10th, then A to the 9th. Well, if it's A to the 9th, B has to be 2, because 9 plus 2 has to equal 11. So we have A to the 9th, B squared. A is x, B is negative 3y. So I go 55 times x to the 9th times negative 3y squared. So the x stays that same way. Negative 3 squared is 9y squared. And so then I just need to multiply the numbers. So 55 times 9, and then x to the 9th y squared. So 55 times 9 is going to give me some sort of number. So that's what? 45 plus 4, so 49. So it should be 495 x to the 9th y squared. Because we were just picking out one of these terms, okay, in this different situation. We didn't have to do the whole thing. Alright, now 7 says write the expression that represents the factored form of this. Okay, so we did it like this one, right? Okay, so the difference is it'll be A minus B and then plus right there, because that's how that one is. If we wanted to go look back, you could. Okay, or it was minus, wasn't it? So I'd go 125 is like 5x cubed minus 216 is 6 cubed. So I'd go 5x is A, So a minus b is 6, times a squared, 5x squared would be 25x squared, plus a times b, 5x times 6 would give us 30x, plus b squared, 6 squared would be 36. And there's my factored form. Okay, now 8 has given us the one with I and wants us to go backwards. Okay, wants us to multiply, which would look a lot like 3. So we're given this version, and we need to go back. So we just find out what a is, what b is, not the I, and then go a squared plus b squared. So 11x is a, so 11x squared, plus 18 is b, not 18i, so 18 squared. So 11x squared would be 121x squared plus 18 squared, which would be 324. I hope that's right. Hope I did my math right there. Looks like I did pretty good. So that's our result. Okay. Now number 9, what is term 6 in row 12? Well, row 12 again, then continue to row 6 and 924. Okay. What is the term 8 of the expanded form of this? 5x minus y to the 9th. Okay. So, power to the 9th. So here's the row we're at. Let's switch over to orange. Okay. And it wants the 8th term, right? So first term, or 0 term, first, second, third, fourth, fifth, sixth, seventh, eighth, 9th. So we wanted the 8th, didn't we? So it was 9. So my coefficient is 9. And then a, b to the something. Okay. So it's the second to last, so here a would be 0. So going backwards, a would be 1. Or in other words, b would be the total, so going backwards it would be a to the first, b to the 8th. Okay, there's a. So 9 times 5x to the first times negative y to the 8th. So 9 times 5 would give us 45, x, and then y to the 8th. It's positive because a negative to the 8th becomes positive. Alright, so the last thing is now, use what you have learned about Pascal's triangle and the binomial theorem to complete all parts of the following problem. So they want 4 terms, not the whole thing, but 4 of those terms. So we've got negative x plus, I left me some space here, 3y to the 7th. Honestly, we'd be better off probably just doing the whole thing, or at least starting to do the whole thing. Okay, so we go to the 7th row, which is right here. Okay, so it's going to be 1, 7, 21. 35, 35, and then back. Alright, so now we need to figure out the a's, right? So it'd be 1, a to the 7th, b to the 0, plus 7, a to the 6th, b to the 1st, because we're going down, plus 21, a to the 5th, b squared, plus 35, a to the 4th, b cubed, plus 35, a to the 3rd, b to the 4th, plus 21, a squared, b to the 5th, plus 7, a1, b6, plus 1, a to the 0, b to the 7th. Now, we could keep going and put a, which is negative x, and b, which is 3y, and figure this all out. But we only need term 1, 2, 5, and 7. Okay? Now remember, it goes 0, 1, 2, 3, 4, 5, 6, 7. So we wanted this one. Okay, so we'll need to figure that one out. 1 times a would be negative x to the 0, b, 3y to the 7th. We also wanted 5, so that would be this one, right? Okay, so 21 times negative x squared times 3y to the 7th. Okay. We also wanted the first and second term. So 0 term first, so it would be 7 times negative x to the 6th, 3y to the first, and the second. Okay, which we'll throw that one down here somewhere. So 21 times negative x to the 5th, 3y squared. And then we just simplify. Okay, so negative x to the 6th would just be positive x to the 6th, 7 times 3y. 7 times 3 would be 21, x to the 6th y. So that's term 1. Okay, so 21, x to the 6th y. Now, the second one down here, 3 squared would be 9y. Negative x to the 5th would be negative x to the 5th times 21. So 21 times 9 would be 189. So negative 189 x to the 5th y, forgot to square the y squared. So negative 189 x to the 5th y squared. Okay. Then term 5, which would be this one. Okay, 3 to the 7th. Oh no, 3 to the... I put a 7 there when I needed to put a 5, didn't I? Hopefully you caught that. So what's 3 to the 5th? Well, 3 times 3 times 3 times 3 times 3. That would be 9. 27. 81. 81 times 3 would be 243. So 243 y to the 5th times x squared times 21. So 21 times 243. I know I'm doing them all by hand and I could do them with a calculator, but go figure. Would be 5,103 x squared y to the 5th. Okay. And then term 7. Okay. X to the 0 would be 1. 1 times 1 times 3y to the 7th. Okay, so we know it's y to the 7th. Now 3 to the 7th would be 3 to the 5th was 243. So we need to times it by 3, times it by 3. So 243 times 3 would be 729. Times that by 3, and that'll give us our number, 7, 6, 7, 8, so 2187. So 2187 y to the 7th. And there we go. Alright?